Hello guys, today we are going through concepts to know. We have average revenue AR, which is this is the revenue per unit of the commodity sold. It is obtained by dividing total revenue by total quantity sold. For a firm in a perfectly competitive market, the AR is the same as price. P is equals to AR. Roman 2 marginal revenue into bracket MR. This is the increase in total revenue resulting from the sale of an extra unit of output. Thus, if TR subscript n minus 1 is total revenue from sale of n into bracket n minus 1 units and TRN is total revenue from the sale of n units, then the marginal revenue of the nth unit is given as DTR is equals to P into bracket 1 minus 1 over ED into bracket or TR subscript n minus TR subscript n minus 1. Roman 3. Total revenue is the money value of the total amount sold and is obtained by multiplying the price of the quantity sold. Necessary and sufficient condition for profit maximization. Two conditions that however prevail, namely Roman 1. The necessary condition is that W over R is equals to MPL over MPK, or MPL over PL is equals to MPK is equals to PK. Roman 2. The sufficient condition is that the isoquant must be convex to the isocost point of tangency. Mathematical approach to profit maximization. If firms choose to sell goods at lower prices, they would sell an infinite into bracket if possible number of goods, forcing all other firms to lower their prices as well. The concept is what gives rise to competitive firm prices referred to as into bracket into apostrophe price takers. Since competitive firms have no control over the price at which their goods are sold, their only hope to maximize profit is to choose optimum quantity of goods to sell. There are two methods by which one can solve for the optimal quantity for perfectly competitive firm to produce and scale here. One, total revenue, which is TR, and total cost, which is TC. Number two, marginal revenue, which is MR, and marginal cost, which is MC. To maximize any equation, we must find where the slope of the equation graph is equal to 0, because the slope of one equation line is equal to the derivative of that equation at a given point. We can maximize a given equation by setting the derivative of that equation equal to 0. 1. Total revenue and total cost. Given total cost is equals to 100 plus 10q plus q squared, P is equals to 50. We must first figure TR. TR is equals to P multiply Q. But since we know P is equals to 50, TR is 50 multiply Q. Profit PI function. PI is equals to TR minus TC. TR is 50 multiply Q. TC is 100 plus 10Q plus Q squared. PI is equals to TR minus TC. PI is equals to 50Q minus into bracket 100 plus 10Q plus Q squared. PI is equals to 50Q minus 100 minus 10Q minus Q squared. PI is equals to 40Q minus 100 minus Q squared. PI is equals to 40Q minus 100 minus Q squared. Next, find the derivative of the profit function, which with respect to Q is equals to 4T minus T2Q. To maximize profit, set the derivative of the profit function equal to 0 and solve for Q. 40 minus 2Q is equals to 0. 40 is equals to 2Q. 20 is equals to Q. To maximize profit, this competitive producer will produce 20 units to sell them at a price of $50. Number 2, marginal revenue and marginal cost. We already know derivative of total revenue over derivative of Q is equals to marginal revenue, or MR. which is the slope of TR curve. Derivative of total cost over derivative of Q is equals to MC, which is marginal cost, the slope of total cost curve. PI is equals to total revenue minus total cost. Find the derivative of the profit function with respect to Q. The derivative of profit function is equals to derivative of total revenue is equals to minus derivative of total cost. To maximize profit, set the derivative of the profit function equal to 0, which is dtr minus dtc is equals to 0, which is the derivative of total revenue minus derivative of total cost is equals to 0. Since we know that those above functions are equal to marginal revenue and marginal cost respectively, we can substitute them into the equation. Marginal revenue minus marginal cost is equals to 0. Marginal revenue is equals to marginal cost. They are both equal. For a competitive firm to maximize profit, they must produce at an output where marginal revenue is equals to marginal cost. Given total cost, which is TC, is equals to 100 plus 10Q plus Q squared. P is equals to 50. Find MR, which is the marginal revenue. So this is a competitive firm. Marginal revenue is equals to P. Marginal revenue is equals to P, where P is equals to 50, 50, 50, 50. So marginal revenue is equals to 50. Find marginal cost. Derivative of D of total cost over total cost is equals to marginal cost. No. Derivative of total cost is equals to marginal cost. Total cost is equals to 100 plus 10Q plus Q squared. So derivative of total cost is equals to 10 plus 2Q. Thus marginal cost is equals to 10 plus 2Q. For competitive firm to maximize profit, marginal revenue must be equal to marginal cost. That is, marginal revenue is equals to marginal cost. So 50 is equals to 10 plus 2Q. 50 minus 10 is equals to 2Q. 40 is equals to 2Q and Q is equals to 20. To maximize profit, this competitive producer will produce 20 units to sell them at $50, price of $50. Note, as can be seen by the above example, these two methods, to bracket total revenue and total cost approach and the marginal revenue and marginal cost approach, have each arrived at the same conclusion. Either one can be used on any problem and the answers derived from each method will always be in agreement. Problem number 1, we have a problem here. We should calculate it. So yeah, let me dictate it. Number 1, given total cost is equals to 70 plus 30Q plus 2Q squared. P is equals to 40. Find the optimal quantity produced and sold by the firm so that they are maximizing profit. So we start with method 1. Total revenue is equals to price multiply quantity. Total cost is equals to 70 plus 30Q plus 2Q squared. Profit function is equals to total revenue minus total cost. Total revenue is 40 is equals to 40 multiply Q. Total cost is equals to 70 plus 30Q plus 2Q squared. Profit function is equals to 40Q minus 70 minus 30Q minus 2Q squared, which goes to negative 70 plus 10Q minus 2Q squared. We will move on to 0 is equals to negative 4Q plus 10 after doing the derivative of total of the PI. Okay, so Q we get is equals to 5 over 2. Method 2, marginal revenue is equals to price is equals to 40, marginal revenue is equals to 40. The derivative of total cost is equals to 4Q plus 30, which is equals to derivative of total cost, which is equals to marginal cost. So marginal cost is equals to 4q squared plus 30, and marginal revenue is equals to marginal cost. So 40 is equals to 4q plus 30. So 40 minus 30, which is equals to 10. 10 is equals to 4q. Q is equals to same 5/2. We move to output prices and efficiency of perfect competition, monopoly, monopolistic competition, oligopolistic competition. Market structures. We defined market structure in the last episode, but we'll reiterate again. This refers to the nature and degree of competition within a particular market. Capitalist economies are characterized by a large range of different market structures. These include the following. A. We have perfect competition. The model of a perfect competition describes a market situation in which there are Roman 1. Many buyers and sellers, to the extent that the supply of one firm makes a very insignificant contribution on the total supply. Both the sellers and buyers take the price as given. Roman 2. The product sold is homogeneous so that a consumer is indifferent as to whom to buy from. Roman 3. There is free entry to the industry and exit out of the industry. Roman 4. Each firm aims at maximizing profit. Roman 5. There is free mobility of resources, i.e. perfect market for the resources. Okay.